So when it comes to PCB Stack-up, if you go online, like right now, you will see that there are lots of, if you Google PCB Stack-up, you see a lot of stack-ups and something like this, um, or there's this coming from Polar. Now, Polar is a very expensive software. Not all companies will have Polar. Okay, Polar is a software for making stack-up and doing impedance calculation. So the reality is, in most cases, you can do stack ups yourself using Excel. As a matter of fact, I like to stack up using Excel because Excel gives me so much more freedom to do whatever I want. And I want to show you how to make a simple stack up in Excel yourself. We'll do the hard ones later, but let's look at a simple one. Okay, let's say a two layer, right? So first of all, you're going to define that layer one and layer two because you have two layer stack up. See, and of course, in layer one and layer two, and then in the middle you have a core, because you're using a core. So let's say you're doing a 62 mil thick board, a two layers. So you have a core. Okay, you have a core, and the core is probably 0.59. Okay, uh, sorry, 0.059, not 0.0.59. Okay, and then, or you can just say it in mil. You know what? Let's make it simple. Just say 59. Um, okay, then I can do something like this. Okay, and I like to color code my stuff, so I'm going to color code my cores. Okay, so my core is always yellow. That's how I set it up. So let's say this is a core. Okay, copper. I usually keep uh, yeah, this color. So it's kind of a copper color. So this is copper. And then we do solar mass. Solar mass is usually green. So let's say solar mass. Okay, that's my color coding. So I got, layer one, 59. I also want to give it define a material that I'm using. So let's say I'm using Isola 370 HR. So I want to say Isola, and I want to say 370 HR. So is the manufacturer is Isola, the model I'm using is 370 HR. So I'm going to do this. And again, once you have your pattern set up in future, you will be like, you can do whatever you want, right? You will figure out how to do it yourself, in your own way. So yeah, so I got Isola 370 HR. What's going on here? Okay. Um, 370 HR 59 mil core. So now, um, here's the thing. I got layer one and layer two. So I also need to define copper on it because, we will have copper. So let's say I do copper. This is my copper. Okay. And then we know is half ounce, I don't know, let's say we are using a half ounce copper. So I would say half ounce. So half ounce, uh, half ounce. Okay, and so this is copper. Then you have a solar mass layer. So we do a solar mass layer, and this is my solar mass layer. Now, the thing is, you also want to define what type of solar mass you're using. So, green color in the stack up usually is for solar mass. There's no specific rule, but that's how people do it. But it doesn't mean that you will have green color solar mass. So you want to define what color of solar mass you want. So, and you also want to define what solar mass you want. So I will say this, you know what? I want to pull it out. Okay. I'll show you why I'm doing this. I'll pull it out. I say, uh, maybe I'm using a tile, and I am using something. Let's say PSR. They have a P. PSR 4000 BN. That's the model number. That's a very common model number that people use. So again, the point is you will figure out which, you will define whatever you're using. So I want to make it white. Okay. So this is your, um, how do you say, your standard stack up. I think this is it. I mean, you don't need to define anything else. You have pretty much everything. And that's exactly how you would make your stack up if you're making an Excel. Okay. Now you want to put down the thickness. So um, you would not, like, if you're a designer, you would not put the thickness for solder mass. It's usually the PCB manufacturers, they will tell you the thickness. But if you are concerned with the solder mass thickness and you work for a company which is very concerned about solder mass thickness, then you can define. But usually you wouldn't. What you would define is, whatever you see here. So let's switch between what designers do and what I do. So let me do kind of stack up that I do. So I would actually define the thickness. So it's 59. Half ounce is actually not zero point 0.5. Half ounce is actually zero point 0.7 mil. So that's ounce over here, and this is in mils. Okay. Solder mass is usually around 1. Okay. So that's the stack up, but we also have, remember, we also have plating. We will plate. So plating is usually, um, usually we do about 1 mil plating. Okay. Plus plating, sorry, I said plus, this is plating, and this is like, okay, this, something like this. Yeah, and then, we can define total thickness, and your total thickness will be equals to sum all of this plus this plus this. 64.4 mil. That's the thickness that we are calculating. Now, that's not bad. 62 mil, usually it's a 62 mil thick, what do you call this? No, you can also define tolerances. So what you want, so let's say total thickness, and you can say, I want plus minus, total this, that's the calculated thickness. So let's say calculated total thickness. Yeah, okay, and you can also say the tolerance is plus minus 10%. So something like this, I would probably put here. Okay, so if you think about it, this is the way you would define a stack up, a simple two-layer stack up, right? It's easy to do in Excel. You can just take a snapshot and post it inside your drawing, or maybe attach it to your spec document, however you want to do, and that's fine. That's how it works. But a couple of things here to note is what the things you need to pay attention to is that you need to define the material, the manufacturer. You need to define the model number or what material you're using, the thickness of the laminate itself. You need to define the copper ounce that you're using, the amount of copper, whether it's half ounce, it could be 1/3, it could be 1/4, but usually it's half ounce or 1 ounce, 2 ounce, 3 ounce, 4 ounce, whatever. So you need to make sure you define it here. And then you need to define the solder mass that you're using, and then the type of solder mass. Oh, I forgot to write the color. So maybe in this case, I wanted to use a blue solder mass. So I would say blue color solder mass. Okay, one thing I forgot here is silk screen. Yeah, we totally forgot silk. You know what? This is not right. I'm saying core, so this is this is silk screen, silk screen, and the green should be, this is, should be solar mask, solar mask, and I would say, maybe make it a little bigger, solar mask, uh, blue, and this is white, okay, and then I would say like this, and now I have my stack up. Okay. Yeah, that's a complete. Now, I'm assuming that this job has two layers, silk screen on both sides. If it's on one side, then you only put one side. So let's say there's no silk screen, you only have silk screen on the top side, then just don't put anything there, okay? And that's how you make a regular stack up. Now, when it comes to silk screen, in most cases, designers are not concerned with silk screen, or meaning who's the manufacturer is, because silk screen is not really doing anything to your design, right? It's just for marking. Only once in a while I see customers asking for the type of silk screen they want the manufacturer to use. Only in those specific cases. Otherwise, not a big deal. So, you just go with um, whatever. It doesn't matter. You don't have to define it. So yeah, here you go. That's your standard stack up, and you can design it yourself as well. Now let's convert this one. Okay, let's convert this one to a four-layer stack up. Okay, so if this is core, I'm gonna insert a pre-preg. Okay, just bear with me. Okay, so this is going to be white. Actually, not white. I usually like to give it this color, and I would say pre-preg. So this is pre-preg, okay, and this is copper, okay. Now pre-preg. Well, what am I doing? I'm using maybe 1080 pre-preg here, and what I'm using is Isola. Again, I'm using 370 HR stack pre-preg because that's the material I'm using. Okay, 370 HR. But then, okay, this layer will also have copper, right? Because when you buy a core, it has copper, just like what we just did. So this would be something like this. So this is layer one. This is, mm, I would say, layer four here. Let me show you why I'm doing this. Okay, layer one. So what this means is that I'm going to go like this, okay, and I'm going to go like this. So what that means is copper is, what I'm going to do is, mm, I'm going, so what I'm going to do is I'm going to do this, okay? This is copper and this is copper and sorry, this is copper and L4 is here. Because copper is a foil, okay? It's like a piece of material, but not just a copper. It's not a core. So that's why I'm defining copper, meaning this is the copper. Like here, I'm running I'm running a extra line here. Anyway, we get back to that in a second. And then this is L2, okay, and this is L3. Now it's like this. There you go. That's your stack up. Layer one, then you got pre-preg, then you have copper, core copper, pre-preg, and whatever you have here. Now you want to define what type of copper it is. So we got copper. Oh, Okay, and this is probably 1 ounce. Imagine this is some kind of ground plane or something. Okay, so 1 ounce. So we got so half is zero point 0.7. So this is 1.4, 1.4, and this is probably much smaller. So let's say this is maybe a 42 mil core. So we do 42. 1080 is probably 3 mil, 3 mil. And the thing is, when you have 1080, well, I don't want to get into how many plies of 1080 you should use, but let's say we are using 2 plies, okay? So if you're using 2 plies, here's what I'm going to do. I'm going to add another and apply here, okay? And apply here and, and apply here. I'm just going to copy this. So basically, I'm using 2 plies of 370 HR prepreg, 1080 prepreg. So 333, and that's what I'm doing. So if you notice, it's calculating to 62.2, and we wanted 62. So that's calculated thickness. Sorry, let me fix something more as well. Calculated thickness, target total thickness, and you probably wanted 62 plus minus 10%. That's how it should be. I'll remove that from here. So that's how you make a stack up in Excel, and it's just so simple to do. Anyone can do it. And yeah, you should learn how to do it, and you don't need to use more really expensive softwares. You use expensive softwares when you want to do impedance calculation for sure, because you can't do impedance calculations in Excel or in anything like that. So for impedance calculation only, you will go to some complicated stuff, complicated software, expensive software. Otherwise, here's how you do it. This is Excel. I just made a stack up in Excel, and I hope you learned something.